Hello friends, we are continuing with data science series with 20 videos. Now today's topic is going to be a different topic, and this is the beginning of time series forecasting using neural networks. So far we were discussing about statistical models. Now we are beginning with the neural network models. So as you can see on the screen, a timestamp time series data which looks like this. See 10, 20, 30, 40, 50, 60, and there's a question mark. What would be the next? That is the question. So how will you achieve this? How will you fill this question mark with an LSTM neural network? So that is what we will discuss today. So what is an LSTM? Long short-term memory networks. You know, LSTM features feedback connections based on neural networks. Now what is a neural network and what is a feedback, etc. we will discuss now. LSTM is better than statistical models for forecasting because neural networks has the ability to implement non-linearities present in the time series data. This is an important point. Now sequence data means, as I already discussed with you, this is a timestamp data and which looks like that. Let's say data which is time sequenced and you would like to predict the future. So the objective of this video will be to introduce you the univariate LSTM model that can learn patterns in a single time series dataset and make predictions for future values based on a given dataset. And what is a univariate time series? These are few new terminologies which you are listening. That is, it's a sequence of measurements of the same variable collected over time. So that is what it means. Now, LSTM. What is LSTM? LSTM is now heard a lot, and people are talking about LSTM in many different technologies. So how will you use LSTM for this forecasting? So LSTM networks, basically they are type of recurrent neural network that uses memory cells to store and manage information over time and allowing them to capture long-term dependencies in the sequential data. So what is a neural network? You must have seen this. A neural network looks like that. A neural network will have the input layer, which is in yellow, and let's say the features are x1, x2, x3, x4, and its output, let's say it has got three output, y1, y2, y3. So this is called input layer, this is called an output layer. These are all hidden layers. It has got 1, 2, 3, 4, 5 hidden layers. Depending on the network, you may not need all 5 hidden layers. You may need less, maybe 1 layer or 2 layer depending on your problem. Now, the way neural networks work is, it tries to achieve the result, and if there is a result, is there a difference between the predicted one and the real one, and they are back propagated to correct the weights and biases in the neural network. Neural networks are basically a very good tuning mechanism. So this is called a fully connected network, and there are some edges, there are some edge weights actually which are involved in this, which I will discuss now. See, to begin with, what is an artificial neural network? It looks like that. See, it has got, let's say, 3 inputs, x1, x2, x3, and there is also a B bias is also involved in that. So you pass it to the first neural network. What is a neural network? Neural network has got a symbol, mathematical manipulation of creating an artificial neuron. You know what it is? It is a summation plus an activation function. What is summation? Simply adding x1 w1, x2 w2, x3 w3. See that? And there is a bias involved in that plus B. So it's basically a summation of all these 4 inputs. That is the first part. Then it goes through a function called g of x. What is g of x? G of x is a sigmoid function. So sigmoid is nothing but 1 divided by 1 plus 1 plus e to the power minus x, something like that. Now, how do you create a combination of multiple neural networks and how it connects together? You can see it here. So the point which you have to remember is actually this neuron produces an output called H1. H1 is nothing but sigmoid of A1. A1 is nothing but the summation of all these. So A1 is also, it can be written as x1 w1 plus x2 w2 plus x3 w3 plus b. So that goes into a mathematical function, sigmoid function, and produces an output H1. So H1 comes, H2 comes, H3 comes, then again they get added again going through another sigmoid function here to get another H. That is how it propagates. Now when dealing with the time series, it tends to forget old information. We wish to have memory in that. So that is where the new technology came in. From a normal neural network, artificial neural network, you could create the recurrent neural networks, which has got a feedback in this. That means the timestamp data are going into this. Suppose there are 10 timestamps. It is not that you create 10 different neural networks. You can have one neural network which is fed back with the different timestamps. So weights and biases changes. So this can be seen, how a neural network looks like. It is looking like this. See, one neural network, there is a feedback. The feedback gets changed every time. That means it is a new weights and biases every time to create a new HT in every timestamp. You can see if you split this into, it is like a 1H0, 1H1, 1H2. These are, each timestamp will have different H values. But with a single neural network, you can feed back to achieve the same thing. It is not that you have to have 1 million timestamps, having 1 million neural networks. In one itself, we can create this with a feedback. And this can be written as HT is equal to f theta, some function with parameters theta, and the prior state HT minus 1. That means you are creating a new HT in every timestamp. That is comma xt, input vector at the current step. In every timestamp x0, x1, x2, like that, different variables comes in. This is a neural network. Now it has got a lot of applications in speech recognition, ECGs, diagnosis, stock prediction, machine translation, video analysis, etc. Now RNNs are improved upon by LSTMs, which address the vanishing gradient problem. If you read why LSTMs are required, it's an advanced form of RNN. RNN has got a problem called vanishing gradient problem. It's a problem that occurs during the training of deep neural networks, where the gradients that are used to update the neural network become extremely small and they vanish as they are back propagated from output layers to the earlier layers. So usually this is an LSTM is expressed like this. There is a forget gate, input gate, and output gate. These things will be discussed in a separate video next. Or in fact, maybe not the exactly next video, next to next video. You may probably see that. Now, here the information which you have to forget is passed here. The input information is fed here, and you will forget certain information, and whatever output is required, it will be brought out. So that is what is the meaning of LSTM. Now LSTM, the RNN looks like that, which I explained to you earlier. So there is a feedback from weight to weight, new weights, and weights and biases get changed, and new HT gets produced, and the activation function can be a sigmoid and it is a tan H here. Tan H has got a better activation, so that is why it is similar to sigmoid. Sigmoid varies from 0 to 1, whereas tan H goes from -1 to +1. So it is a more dynamic range. And LSTM looks like this: input gate, output gate, etc. We will discuss it later. Now LSTM can be used for time series prediction. LSTMs learn patterns and dependencies in sequential data and address the vanishing gradient problem, which we discussed a bit earlier. Now, this makes LSTM effective for time series prediction, where information from earlier parts of the sequence is required for making predictions. Now, a basic program for LSTM forecasting, that will be the next video, and that will be discussed in the next video, but at the same time we will go through it a bit. It is like so these are the different libraries required for all these, and then see, this is a matplotlib, this is the numpy, this is a keras is also required, and all these libraries are required. And you have a data set which are let's say you have data 10, 20, 30, 20, 30, 40. These are different rows. Let's say you have 4 rows which looks like that, and you have you have certain columns also. Now, so here you can see that it is a 4 rows and 3 columns. So the shape is 4 into 3. Now you are having the outputs 10, 20, 30, the output is 40, 20, 30, 40, the output is 50. For this is the output. So this is called windowing, which will be also discussed in the next video in detail. So you have to do a reshaping. Reshaping is nothing but you are making a 2-dimensional array into a 3-dimensional array to be passed into the LSTM model. LSTM model accepts only 3-dimensional matrix. So X shape will be 4, X shape 1 will be 3, and this is 1. And since it is a univariable data, that is like a sequential data, this has to be 1. Now reshaping is nothing but you are converting the 2D array into a 3D array. For example, let's say day 1 temperature looks like that. There are every day 1 hour's temperature you are taking, that means 24 temperatures, day 1, day 2 and day 3. So that means each day acts as a sample. That means there are day 1, day 2, day 3. So they are different samples. Time steps are each hour is a time step. So that means you have the data which looks like this. There are 24 such data in each day, and it's expressed in 3 multiplied by 24. This is the matrix. Now each day's temperature data becomes a separate sample. So each hour's measurement becomes a separate time step. Now after reshaping, it converts 3-dimensional matrix into a 1-dimensional, 3-dimensional, and after reshaping, it converts 2-dimensional array into a 3-dimensional array. And this is how it is doing this. This is being passed into the model, and model is called model is equal to sequential. And here ReLU is used as a function, and in LSTM has got 50 neurons, and this is how a 50 neurons model is going to be created now using neural network. The first time in the videos we are explaining about how to create a neural network model. Now after a LSTM layer, a dense layer is added to the model, and it has got the dense layer has 1 neuron, and it will produce the final output of the model. And now MSE is the mean square error is used as a loss function, and Adam is optimizer. Now you are calling the fit function, model.fit, and you are now training starts for epochs is equal to 1000. After all these things, actually you have to again now convert the X input into an array, X input by an array format which is looking like this, and you will predict the output into a Y hat. Now X before reshaping would look like that, after reshaping it would look like that, and the new input is looking like that. So now it's able to predict a new value. That is how LSTM works. And a practical implementation of this will be demonstrated in the next video. Thank you.